All right, ladies and gentlemen, today is our last day of notes here for this Unit 1. And, yeah. Yeah, go ahead and sign out. And we are talking about the real number properties. And these are the properties that you guys have been using all through elementary school, okay? But now we put a name to them. And maybe you know them already. I remember one day talking and my daughter was like, is that the commutative property? And I was like, oh my God. Okay. Sort of always interesting when one of my own kids talks math at me and I'm like, wow, cool. I'm glad you know that. Anyway, so we are going to be able to identify and use the properties of real numbers here. And so in math, properties are statements that are true for any numbers, all right? They're always going to be true. And they help us justify our steps when we are simplifying expressions and solving equations. So these are all these statements that we need to understand are true all the time so that we can apply them in the future. And if we understand this, then we always want to say, hey, is what we're doing allowed? Is it legal? Is it mathematically true? And that's how we go through our math, making sure that what we're doing is true and makes sense. So the commutative property is the first one we're going to talk about. The commute, in the word here, I need a highlighter. The word there, the root of the word is commute. And when I think of commute, I think about my commute to and from school, okay? So I drive from my house and I come to school, and that's 7 miles. When I start at school and go home, is it still 7 miles? It's the same distance whether I start at home and come here or whether I start here and I go home. I drive the same path. Okay, and so this is my commutative property. The main idea is the order does not matter with addition and multiplication. Addition and multiplication. The order that we add or multiply does not matter. So, for instance, the commutative property of addition says, hey, 4 plus 5. 4 plus 5 is the same as 5 plus 4. And you guys know that. You've been doing that since elementary school, right? Sometimes it's easier. Like 4 plus 10, it's a lot easier to add 10 plus 4, right? All right, but we get the same answer either way, okay? And so what we're doing is we're just switching the order of those numbers, and the addition will work out fine either way, okay? So for multiplication, all right, let's see, 7 times 2 is the same as 2 times 7. The order that we multiply doesn't matter. We can change the order of the numbers and we're going to get the same thing. Okay, so now we could use regular old numbers, or I can say I'm going to use letters instead to represent my numbers. So maybe I might say A plus B is the same as B plus A. All right. Similarly, we can multiply. Maybe I'm going to say instead of using numbers, I'm going to use X times Y is the same as Y times X. All right? So the order of those variables doesn't matter. That is the commutative property. And the same is true if I get really algebraic here. I could say something like negative 3x plus 8 is the same as 8 plus a negative 3x. All I'm doing is swapping the order there of those two items, the negative 3x and the positive 8. Okay, they're just trading places. This one is kind of interesting. Under multiplication, I might write something like 3 times x plus y. So I have 3 times a group is the same as the group times 3. 3 times the quantity x plus y is the same as the quantity times 3. So all I did is trade places, all right? And that's the commutative property. We're going to get the same answer either way. All right. Questions on the commutative property? All right. Well, it's pretty easy, right? All right. Next we have the associative property. The associative property, again, I like to look at the word associate. That's the root of the word. What does it mean to associate? Who do you associate with? People in your class, your friends, okay? And so the main idea for the associative property is that grouping associative groups, who you're associating with, who you're being grouped with. Who you're being grouped with doesn't matter with addition and multiplication. So I like to think about these as associative groupings. So who you're being grouped with doesn't matter in multiplication and addition. So for instance, maybe I'm going to add a bunch of things together. So maybe I want to add 7 and 8, and maybe I'm going to add those two first, and then I'm going to add a 9. So if I'm adding 7, 8, and 9, I can start with 7 and 8 first, and then I can add in the 9. Am I going to get something different if I add 8 and 9 first, and then add in the 7? Or do we get the same thing? Yeah, 15 plus 9 is 24. 17 plus 7 is also 24. So here you can see what's changing from the left side to the right side. What's different? Just the parentheses, yeah? The numbers didn't change order. It's still 7, 8, 9, 7, 8, 9. But I changed who we were associating first, who we were grouping up first, okay? Here we're grouping 7 and 8. Over here we're grouping 8 and 9. Does it matter? Or do we get the same thing on both sides? We get the same thing on both sides, okay? All right. Super. Again, I can, instead of using numbers, I can represent it using different letters. So maybe I'm going to say, hey, x plus y, let me add those up and then add in z. And that's going to be the same as x plus the quantity y plus z. So again, I can represent things just using letters instead of numbers. It means the same thing if I add the y and z together first and then add in the x. I'm going to get the same result. Doesn't matter who I group, okay? What about multiplication? Is this true for multiplication? Let's think. So multiplication, maybe I'm multiplying 3 times 5 times 2. And maybe I want to start by multiplying 3 and 5 together. And that's going to be the same as, what might be an easier way to multiply these numbers together? 2 times 5, yeah. So if I have, maybe I want to do the 5 times 2 first. I'd much rather get a 10 and then multiply it by 3. But I'm going to get the same result either way. 15 times 2 is 30. Over here, 10 times 3 is also 30. All right, so again, how we group things is not going to change our answer. We're going to still get a valid result. All right, let's see. Again, maybe I want to represent this not using numbers, but we can show the same thing using letters and multiplying. Maybe we're multiplying A times B times C together, but I'm going to group A and B first. And I'm going to get the same result if I multiply 3 things together, but I'm, in this case, going to multiply B and C together first. All right. Any questions on the associative property? Associative property, we're looking at the grouping symbols. And so does this work with subtraction? No, it doesn't work with subtraction. All right. And so just to show you it doesn't work, we could be like, I don't know, give me a number. 4. All right, I heard a 16. So 4 minus 16 minus 3. And then, let's see, 4 minus 16 would be negative 12, and then minus 3, we would get negative 15. Now, let's change our associative groupings here. I'm going to use the same exact numbers, but now I have to change my associative groups here. All right, let's see. So first, we would do inside the parentheses, what's 16 minus 3? 13. So we'd have 4 minus 13. And what's 4 minus 13? Negative 9. Are these the same? No, they don't equal each other. So it doesn't work with subtraction. The same is true. It's not going to work with division. Addition and multiplication are very, very special. Okay? Subtraction messes everything up. Okay? So you have to be pretty careful. Okay, the identity property, the identity is the main idea here for the identity property is that we keep the value of the number. And so what we're doing is we're saying, hey, what can I add for addition? What can I add if I start with a 5? What can I add that's going to result in the same exact value? What can I add to 5? 0. That is the identity property. If I add a 0, I keep the value the same. If I'm using letters, x plus what is going to keep an x? X plus 0 is going to keep my x the same. It's not going to change it. All right. If I have a negative 9 plus what is going to keep a negative 9? 0. All right. So the identity property is what can I add that's going to keep my start and my end the same. I can add 0 all day and night and not change the problem. Okay. For multiplication, same idea. If I start with like a 12, what can I multiply to still keep a 12? 1. I can multiply by 1 all day and night, and it's not going to change what I started with. So if I have a 3/4 times what? Still going to give me 3/4. 1. 3/4 times 1 still gives me 3/4. If I have a 9x times what is still going to keep the same exact thing? 1. Okay. So the identity property is what we start and where we end matches. It's like an identical thing. Identity, identical. Okay. So what do we add or what do we multiply to keep the same identical thing? Does that make sense to you? Okay. Do you see how I'm connecting the word to the math here? Identity, identical. All right. Okay, questions so far? All right, let's keep going. We're almost done. All right, right, so the inverse. Inverses are very important. An inverse is it sort of uses the, I'm going to put opposite, and I'm going to put that in quotes because I don't really like it. It uses the opposite to, I'm going to say undo instead of her word here. It uses the opposite to undo something. So let's see, inverses. 10 plus some number is going to give me 0. 10 plus what gives me a 0? 10 plus negative 10. Those are inverses. That is the additive inverse, the number that I can add to it to make it cancel out, to make it undo itself. If I have negative 5 plus some number is going to also equal 0. What? Negative 5 plus what? Yeah, negative 5 plus 5. Those are additive inverses. Let's see. 4x plus what gives me 0? Negative 4x. Very good. Positive 4x, negative 4x. They are additive inverses. And they basically undo one another. So we have nothing left. Okay? Now for multiplication, slightly different. Let's say I start with 1/2. 1/2 times something. I want it to cancel itself out. I want it to undo itself. 1/2 times what gives me 1? 1/2 times half of 2. Half of 2 gives me 1. These two things are inverses of one another. They cancel each other out, all right, and give us a 1. All right, let's see. What if I have 5? 5 times what is going to give me a 1 here? Well, 5 times negative 5. 5 times negative 5 is negative 25. So that doesn't cancel itself out. It gives me something different. 2 times 1/2 gives me 1. 5 times 0 gives me 0. But I want a 1 here. Yes, very good. 5 times 1 over 5. 5 times 1/5, well, that 5 times 1/5 would give me 5 over 5. And what is 5 over 5? 1. 5 goes into itself 1 time. Okay. All right. Let's see. So negative 7/2 times something is going to equal 1. Negative 7/2 times yes, very good. Negative 2/7. These are reciprocals. All right, the fractions are flipping. We're flipping those fractions. Let's see. Negative times negative gives me that positive I'm looking for. And 7/2 times 2/7. Remember, to multiply fractions, we go straight across. 7 times 2 is 14. 2 times 7 is 14. What's 14 over 14? 1. Okay. And so if I have a fraction like a over b times what gives me 1? B over a. These are reciprocals of one another. A over b times b over a cancels each other out, leaving 1. Okay? So that's the inverse. What cancels it out or undoes the other. That's how we think about that. All right, questions on that one? All right. The zero property. The main idea is anything multiplied by 0 Anything multiplied by 0 equals 0. Anything multiplied by 0 equals 0. Let's see. So if I have a 5x times 0, what does it equal? 0. If I have a plus b times 0, what does it equal? 0. All right. It doesn't matter. If it's times by 0, the whole thing's going to equal 0. All right, the last property we're going to talk about is the distributive property. And this is the important property that we're going to spend a lot of time on in the next unit. So today we're just getting an introduction to it. So the distributive property is multiplying a value to an expression, multiplying a value to an expression in parentheses. P-A-R-E-N-T-H-E-S-I-S. Parentheses. It's got parent in the word. Sorry. I just realized that. They're motion censored. All right, multiplying a value to an expression in parentheses. So the distributive property we use all the time. And so maybe it's something like this. We have 5, quantity x minus 2. What operation is between the 5 and the parenthesis here? Multiplication, always, always. There's a multiply sign, and that's very important. And so what we're going to do is we get to distribute that 5 to each person inside the parentheses. And we multiply. 5 times x is 5x. They just get stuck right next to each other. That's kind of nice. And then here we say, what's 5 times negative 2? Negative 10. And that's the distributive property. We're sort of sharing the 5 into the parentheses. Let's look at another. We're going to do a few of these. Negative 7 times x minus 2y. So again, this is negative 7 times the whole group. And so it wants to be shared. We want to take negative 7 and share it to both things inside the parentheses. So what is negative 7 times x? Negative 7x. Easy. They just get stuck together. And now we have negative 7 times negative 2y. Yeah, negative times negative is going to give me positive. So change the sign, life will go a lot easier. And then 7 times 2y becomes 14y's. We can multiply the numbers together. 7 times 2 is 14 with a y. How many of you have done distributing before? Okay. All right. Let's do one more here. Let's do negative 3 times 2x plus 2y. Oh, let's make it different. Let's make it 5, just so. Plus 5y. Negative 3 times the quantity 2x plus 5y. Again, we're right next door to parentheses, so that means multiply. And so I need to take that negative 3 and I need to multiply it to both things inside. Do you see my little rainbow arrows? You should draw those little rainbow arrows because they're helpful later on. All right, here we go. Negative 3 times 2x. What's that going to give us? Negative 6x. Very good. Negative 3 times 2 is negative 6, and we also want to keep our x on there. And then I have negative 3 times positive 5y. What is negative 3 times a 5y? Negative 15y. Very good. Negative 3 times positive 5 is negative 15, and keep your y on there. Okay. Now, with only letters, here we go. A times the quantity B plus C. This is how we see this property normally. Last turn around. So here we have A times the quantity B plus C. Again, we got to share the A to both letters inside the parentheses. So this is A times B. How do I write that in math? AB. That's it. When they're right next to each other, there's a times in there. And then we have A times the positive C. AC. A positive AC. And so this is how we normally see this property. When we see something like that, you got to know that that was the distributive property that we were doing there. Okay? Do you guys have questions for me right now? Okay. So what we want to do in these last few questions here is figure out what property that this is identifying here. All right, what do you notice in number 1? What's changing? The parentheses, the groups are changing. So what property talked about the groupings? Associative. The associative property of, is this addition or multiplication we're looking at here? Addition. The associative property of addition. All right, look at number 2 here. What property does this look like? We start with parentheses. Do we have any more parentheses over here? Distributive. Yeah, this is the distributive. They're taking the 2 and they're sharing it to both parts there. 2 times x and then the 2 times the 9. So this is the distributive property. distributive. Distributive property. Here, we're starting with a 2x and we're ending with a 2x. What property starts and ends the same? The identity property, yeah, identity. This is the identity property of multiplication. Very good. Of multiplication. Identity property. All right, look at number 4. What's changing from the left side of the equals to the right side of the equals? Are the parentheses changing? The letters are trading places. So here we have m plus n, but on the right-hand side, it's n plus m. So they traded places. What property allows us to trade places? Commutative. Yeah, this is a commutative property. The commutative property of, are we multiplying or adding here? Adding, addition, yeah, commutative property of addition. What property says, hey, take something and times by 0 and it equals 0? What property is that? Property is 0. 0 property, very good. 0 property. If we multiply by 0, we're going to get a 0. All right. What's changing here on number 6? What did you say? The order. Yeah, we have 7 times the group. On the right-hand side, we have the group times 7. So they're trading the order. What property trades the order of things? The commutative property. The commutative property of multiplication. Yeah, we are multiplying 7 times the group and the group times 7. All right, 7 and 8. Name the additive inverse of 16. What's the inverse of 16? Negative 16. Good. What's the multiplicative inverse of 3/7? 7/3. Very good. All right, ladies and gentlemen, that is it for me. Keep those handy as you're going through the Delta Math today.